You are tasked with building a classification model for a dataset with a large amount of unlabeled data and limited labeled data. Which scikit-learn semi-supervised learning technique would be most suitable for this scenario? A. Label propagation exploits the graph structure of the data to propagate labels from labeled to unlabeled samples. B. Label spreading similar to label propagation, but utilizes a diffusion process to distribute labels more smoothly. C. Self-training, a method where a model trained on labeled data is used to predict labels for unlabeled data, and the most confident predictions are added to the training set. D. All of the above. Correct. Label propagation is a semi-supervised learning technique suitable for scenarios with a large amount of unlabeled data and limited labeled data. It leverages the graph structure to propagate labels from labeled to unlabeled data points. This technique is effective when data has a clear underlying structure or relationships. Correct. Label spreading, similar to label propagation, is another semi-supervised learning technique suitable for scenarios with limited labeled data and abundant unlabeled data. It leverages the graph structure, utilizing a diffusion process for smoother label distribution, potentially enhancing performance in cases with noisy data. Correct. Self-training is also a suitable technique for scenarios with limited labeled data and abundant unlabeled data. It iteratively trains a model on labeled data, then predicts labels for unlabeled data. The most confident predictions are added to the labeled data, refining the model. Correct. All the mentioned techniques, label propagation, label spreading, and self-training, are effective methods for semi-supervised learning in scenarios with a large amount of unlabeled data and limited labeled data. Each technique offers a different approach to leveraging unlabeled data, making them valuable tools for improving model performance. D. All of the above. A machine learning paradigm where the training data consist of both labeled and unlabeled examples. The goal is to leverage the unlabeled data to improve the model's performance. This technique assumes a graph structure where nodes represent data points and edges represent similarities. It propagates labels from labeled to unlabeled nodes based on their connections, similar to label propagation, but it uses a diffusion process to spread labels more smoothly across the graph. This can lead to better performance in cases with noisy data. A model is initially trained on the labeled data. Then, it predicts labels for unlabeled data. The most confident predictions are added to the labeled data, and the model is retrained iteratively, using a large amount of unlabeled images along with a smaller set of labeled images to train a model to recognize different objects or scenes. Categorizing large amounts of text data, e.g., emails, articles, into predefined classes with limited labeled data. Grouping customers into distinct segments based on their purchasing behavior, demographics, or other factors. Using labeled data to define initial segments and leveraging unlabeled data to refine them. Let's say we have a dataset of 100 data points with two classes A and B. We have only 10 labeled data points. We can use label propagation to propagate the labels to the remaining unlabeled data points. In this example, we would first create a graph structure where each node represents a data point and the edges represent the similarity between data points. We would then use the labeled data to seed the graph. The algorithm would then propagate the labels from labeled to unlabeled data points based on their connections. Python. From sklearn, semi-supervised import label propagation. From sklearn, datasets import makemoons. Import numpy is np. X, y makemoons n samples 100. Noise 0.1. Random state 42. N labeled 10, X train unlabeled, Y train YN labeled, Z unlabeled unlabeled, unlabeled NP, 0 slings unlabeled. Model label propagation kernel RBF, gamma 0.1, model, FitX, NP, concatenate train, unlabeled, predicted labels model, predictx unlabeled. This code snippet demonstrates how to apply label propagation to a dataset with limited labeled data. Using the scikit-learn library, a semi-supervised algorithm that uses a graph structure to propagate labels from labeled to unlabeled data. The algorithm is based on the idea that similar data points are likely to have the same label. The label propagation class in scikit-learn implements this algorithm. The kernel function defines how the similarity between data points is measured. In the example code, RBF radial basis function kernel is used, which measures the distance between data points in a radial basis function. The gamma parameter controls the width of the radial basis function. A smaller gamma value means that the influence of nearby data points is stronger, while a larger gamma value means that the influence of faraway data points is also significant.